Hello, this is problem number 52 from chapter 1 from the Openstax Physics Volume 1 book. Okay, the reference is given below. It's a free book. So how to solve this problem? Let's read the problem first. Consider the physical quantities mass, displacement or distance traveled, velocity, acceleration and time with dimensions. The dimension of mass is given, dimension of length is given, dimension of velocity, acceleration and time is given. So dimensions means any physical quantities can be expressed in terms of basic quantities like mass, length, time, etc. Okay, so now the question is, look at this equation. Force is mass into acceleration, and we need to find out what is the dimension of F. Okay, so the given dimensions are, you see the square bracket represents the dimension of mass is capital M. For the distance traveled or displacement is L. Velocity is Lt raised to minus 1. Acceleration is Lt raised to minus 2 and T is capital T. So now let's take the first one, A. That is, force is equal to mass into acceleration. Now what is the dimension of MA here? So you put it in square bracket, MA. So what is the dimension of M and A? So M is capital M for this term, and acceleration, we know it is Lt raised to minus 2. So in effect, the dimension of force is equal to mLt raised to minus 2. That's it. So let's take the second one. This is kinetic energy actually, which is equal to 0.5 mass velocity square. So K is equal to 0.5 mv square. So what is the dimension of the right hand side, which is equal to the dimension of K? So the dimension of mv square is a constant we need to worry about. M is capital M again. Velocity, the dimension is Lt raised to minus 1. So if you substitute M into Lt raised to minus 1 squared, so this turns out to be ml square T raised to minus 2. So you square this term. So this is the dimension of kinetic energy. The third one, momentum, P. P is equal to mass into velocity. Same procedure. Find the dimension of mv. Substitute the dimension of mass and velocity. Velocity is Lt raised to minus 1 and mass is m, which turns out to be mLt raised to minus 1 is the dimension of momentum. Next one, the work done is mass into acceleration into displacement. Okay, so here mass into acceleration is actually force. So force into displacement or mass into acceleration displacement. So let's see in the dimensional analysis, what is the dimension of MAS, which is mass, and for acceleration it is Lt raised to minus 2. Substitute here into L. S is L, right? So in the end, L into L is L square. So it gives ml square T raised to minus 2. So one thing you can note here is mLt raised to minus 2, and for kinetic energy also it is mLt raised to ml square T raised to minus 2. Here also it is ml square T raised to minus 2. So kinetic energy and work, they have the same dimensions. Both are energies basically. Now angular momentum L. Angular momentum L. We will learn these things in later chapters actually. Mass into velocity into radius. So radius means it is length. Okay. Velocity is Lt raised to minus 1. M is mass. So if you substitute mass, Lt raised to minus 1 for velocity, R is a distance basically, right? radius, it's a distance, so it is L. So it gives you ml square t raised to minus 1.